Hello guys, how you doing? This is the fourth session of chapter 2 of Fluid Mechanics 1. I hope you are doing well. The subject of this session is measurement of pressure. Follow me through the whole video. So, as I have already told you, the subject of this session is measurement of pressure. My name is Amirreza Talaqat and my email address is amirrezatalagat@gmail.com. I'll be so much delighted to answer all of your emails. It might take several minutes to several days, but I try to answer them as soon as possible. Don't worry about it. So look forward to the section. You know guys, we have two types of pressure. One is absolute and the other is gauge. The absolute pressure is regarded from the reference, is relative to the perfect and absolute reference. And it is always positive. Absolute pressure is always positive. Nevertheless, we have the gauge pressure. Let me just remind you that the absolute pressure is the combination of gauge pressure plus atmospheric pressure, which is local. Atmospheric pressure is local. Another point of gauge pressure is that it might be having negative sign. Negative sign of pressure gauge means suction, which is something like that. Suctioning the air through the lungs. This means that it is happening something like this. And an example of absolute pressure, we can have 10 psi absolute. As long as we have local atmospheric pressure as an amount of 14.7 for psi unit, pound per inch square, the gauge pressure is minus 4.7 psi's, which is vacuum or suctioned pressure. Guys, let me just remind you that be so much careful about your units and their homogeneity of equations. It is really important. And one more time, I'll tell you that the pressures that we are considering in the whole fluid mechanics, and most importantly in fluid mechanics 1, are gauge pressures, as long as we have not mentioned the absolute term. For example, we have 10 psi A. This means 10 psi absolute, or 100 kilopascals absolute. The absolute term is mentioned in here. So the absolute pressure is the combination of gauge pressure plus atmospheric local pressure. Local atmospheric pressure, which is here. If we have a minus pressure, it is gauge pressure and it is vacuum or suction. But the sign of absolute pressure is always positive. So, how we can measure the pressure difference? This is the question. We have a measurement instrument which is named as barometer. Barometer has a mercury in it. It is in like a tube. If we pour the mercury in a tube and upside it down to the bottle, the whole the whole of the down bottle is going to be filled with the mercury as long as it reaches to the balance. The balance is going to be gained by weight force and the pressure of vapor, which is here. When we have a balance, the pressure of here is going to be equal to gamma H plus pressure of vapor, which is this empty section. Despite all of this, since the pressure vapor is having such a little amount, we are not considering it since the amount is 0.00023 pound per square inch, which is so much low. So let me illustrate an example to you to verify the barometer calculation. Follow me with the example 2.3. Welcome guys to solving example 2.3 from chapter 2 section 2.5, which is about barometric pressure. The question is, a mountain lake has an average temperature of 10 degrees centigrade and a maximum depth of 40 meters. The barometric pressure is 598 millimeter mercury. millimeter mercury. The question wants us to find out the absolute pressure in pascals at the deepest part of the lake. So, in order to solve this problem, we should utilize this formula. P is equal to gamma H plus P0. As we know, the P0 is absolute pressure. So this means P0 is local atmospheric pressure, which means P barometric divided by gamma Hg is equal to 598 millimeter mercury or millimeter or 0.598 meters. If we have gamma Hg, since we have gamma Hg as 138 kilonewton per cubic meter, this means that P0 is equal to gamma Hg plus the height, which is 0.598 multiplied by 133 kilonewton per cubic meter multiplied by meter, which is 79.5 kilonewton per square meter. From table B.2 at 10 degrees centigrade, we have gamma H2O as 9.804 kilonewton per cubic meter. So the total absolute pressure is equal to 9.804 multiplied by 40 plus the P0, which is 79.5. It is meter, kilonewton per cubic meter, kilonewton per square meter, we're gonna have 472 kilopascal. So the total absolute pressure is 472 kilopascals. Guys, pay attention to this point. As we have P barometric as 598 millimeter mercury, the height would be P barometric divided by gamma Hg, which is 598 millimeter, which is 0.598 meter. The main point of this question is this formula. And second to that, this formula. Welcome back, guys. There is just one point left. I want to explain it to you here. Guys, barometer is the category, is one of the subcategories of measurement device manometer, which is gonna be illustrated in the following session. So guys, this is the end of fourth session of chapter 2 of Fluid Mechanics 1. I hope you have acknowledged the whole subjects of this session, and I'm very happy that you have followed me till this moment of video. And I'll be so much appreciated if you notify, if you subscribe the channel in order to get the notification of all upcoming videos. I bid you all farewell. See you in the next session.